Every time you pull into a gas station, you are standing on top of a sealed underground pressure system, actively managing explosive vapor. And the nozzle in your hand, that's not a handle. It's the surface and point of one of the most quietly engineered safety systems in modern infrastructure. Most people never think about what's beneath that concrete forecourt. A few buried tanks, maybe some pipes. Simple, right? Turns out, the simple part of a gas station is the most dangerous engineering problem ever handed to a suburban parking lot. Because gasoline vapor, not the liquid, the invisible stuff you can't see, is what actually wants to explode. And for decades, early gas stations were basically open-air fire hazards, sitting inside American neighborhoods. So at some point, engineers had to completely redesign how a gas station works. Not to sell fuel more efficiently, but to contain something deadly and invisible. Here's what they built. Picture what most people imagine when they think about how a gas station actually works. There's a big tank in the ground. A pipe runs up to a pump. You squeeze a handle and fuel comes out. Basically, a garden hose with a price display. That's the mental model almost everyone carries. And honestly, it makes sense. Nothing about a gas station forecourt screams complexity. It's concrete, a canopy, some numbers on a sign. The whole setup feels about as engineered as a kitchen faucet. And that assumption is exactly what makes this story so strange. Because the moment you start pulling on that thread, asking what's actually buried under that concrete slab, the simple tank and a pipe picture just falls apart. The real system underneath you is managing pressure, capturing invisible explosive vapor, and actively preventing a slow-motion environmental disaster, all at the same time. Every single second the station is open. Not occasionally, constantly. So before we get into what engineers actually built, it's worth sitting with that original assumption for just a moment longer. Because the reason this engineering went unnoticed for so long is precisely because it was designed to be invisible. And the thing it was hiding from you, the reason all of this had to be built in the first place, is a lot more dangerous than most people realize. Gasoline itself is actually pretty hard to ignite. Pour it on concrete and throw a match, it might not even catch. But let it evaporate for a few seconds. Now you have a problem. Gasoline vapor mixes with air in a ratio that becomes explosively flammable. And unlike the liquid, you cannot see it. You cannot smell it until it's already everywhere. And it's heavier than air, which means it sinks and spreads along the ground, looking for any spark it can find. Early gas stations had no containment for this at all. Fuel moved through open pipes, tanks vented freely into the atmosphere, and spills just soaked into the earth beneath the forecourt. For decades, well into the 1970s and 80s, underground storage tanks across the country were quietly leaking, sending gasoline vapor into the soil and liquid fuel into municipal groundwater. People were being poisoned slowly by infrastructure that looked completely normal from the street. The redesign of the modern gas station was not driven by a desire to pump fuel faster or cheaper. It was driven by the realization that the invisible byproduct of selling gasoline was doing damage nobody could see until it was catastrophic. Which means the question becomes, who finally decided to do something about it? And what exactly did they build? The fix came in two stages, and the second one is built into the nozzle you hold in your hand right now. Stage 1 is what happens before you ever arrive. When a fuel delivery tanker backs up to a gas station, it doesn't just pump gasoline down into the underground tank. It also connects a second sealed hose, a vapor return line, that runs straight back into the tanker. As liquid fuel flows in, the vapors being displaced have nowhere to escape. They travel back up through that return line, into the tanker's own sealed compartment. The whole transfer happens in a closed loop. No vapor reaches the air. Most people drive past this happening every week and have no idea what that second hose is for. Stage 2 is yours. That nozzle you click into your car's filler neck, it has a second tube running through it. A small rubber sleeve seals around your fuel inlet when you insert it. As gasoline flows in, the vapors being pushed out of your tank don't escape into the air around you. They get actively pulled back down through that second tube, through the pump, and back underground into the storage tank. That faint hiss you sometimes hear when you're filling up, that's not a broken pump. That's the system working. That's vapor being recovered in real time, right at the point of contact. It's a sealed circuit running from the ground through the pump, through the nozzle and back. Every fill-up, every time. But here's what that raises. If vapor is constantly being pushed back underground, from deliveries, from fill-ups, all day, every day, where exactly does it all go? And what stops it from building into something catastrophic? Those pipes on top of the gas station canopy, the ones you've probably never once looked at, they're not exhaust vents. They're not HVAC. They are the pressure relief valves for everything happening 30 feet below your shoes. Here's what's actually going on. The underground tank isn't just sitting there, full and still. It's breathing. As fuel gets pumped out, the space above the liquid inside the tank changes. Pressure shifts. Temperature shifts. The vapor inside expands and contracts depending on the time of day, the season, how busy the station is. And that pressure has to go somewhere. Otherwise, you'd be building toward exactly the catastrophic situation the whole system is designed to prevent. So the tank vents upward, through a sealed pipe that runs all the way to the top of the canopy, sometimes disguised as a plain vertical pipe you'd never think twice about. That pipe releases controlled pressure to the atmosphere in tiny, managed amounts. It is a pressure negotiation, running constantly between the tank underground and the air above, and it never stops. But that's only half of it. While all this pressure balancing is happening, sensors embedded in the tank walls are continuously monitoring for micro leaks. Gaps so small they are invisible to the eye, but large enough to let fuel seep into the surrounding soil over time. Under EP, a mandate that monitoring happens around the clock, not once a week, not during inspections, constantly. Think about that. A single gas station forecourt contains more active, real-time pressure management engineering than most industrial facilities. And it's all running silently, underneath ordinary concrete, in a place you stop to grab a coffee. Which makes you wonder, what were gas stations doing to the ground and to the water before any of this existed? The answer is worse than you'd expect. Before modern regulations, underground storage tanks leaked constantly, and nobody was required to know. Gasoline seeped into soil and found its way into groundwater supplies across the country. One of the worst culprits was a fuel additive called MTBE, used to make gasoline burn cleaner, which turned out to contaminate drinking water at even trace levels. And it spread fast. Thousands of municipal water sources were affected. That quiet disaster accelerated the push for sealed systems, leak detection and vapor recovery nationwide. And here's what changed above ground. Cities got cleaner air. Ground-level ozone, the kind that triggers smog warnings and damages lungs, dropped measurably once vapor recovery became mandatory. Because those fumes were no longer escaping into the atmosphere every time someone filled a tank. That faint fuel smell you barely notice at a modern pump. In the 1970s and 80s, it was thick. The difference isn't your memory, it's a hose fitting. But all of this engineering only works if the person holding the nozzle is part of the system too. That click you hear when the nozzle locks into your gas tank, that's not a convenience feature. That's you becoming part of a sealed pressure system. The slight resistance you feel when you squeeze the handle, the way it pushes back just a little, That's vapor recovery doing its job. Fumes that would have drifted into your lungs or seeped toward a storm drain are being pulled back underground the moment that seal forms. The automatic shutoff that stops the flow before you overflow the tank. That's a pressure sensor, reading the system in real time. Every single thing you touch at a pump has been engineered to close a loop that most people never knew was open. Beneath your feet right now, tanks are flexing with temperature changes, sensors are checking walls for micro leaks, and vent pipes are quietly balancing pressure between the underground and the atmosphere. The whole forecourt is breathing. It's been doing this every hour of every day for decades, protecting your groundwater, cleaning your air, keeping an invisible explosive contained. And nobody ever told you. So the next time you pull up, look at that nozzle before you grab it. It's a small piece of metal. It looks like nothing, but it's the last valve in a system that changed the air quality of every city in America. That's not a gas pump. That's infrastructure pretending to be ordinary. There's so much hidden engineering in the everyday things around us. I go looking for it every week. Subscribe and there's a lot more of it coming.